Hello guys, welcome to DST classes. In today's class, I will explain about what are data objects used in VHDL. So VHDL is a hardware description language. So HDL will describe the behavior of a hardware. So mainly HDLs are two types, VHDL and Verilog. So we use VHDL. In VHDL we have different types of data types. So mainly to understand what are the how we can write the identifiers in this. So basic language elements are user identifiers and keywords. So user identifiers, so a identifier in VHDL is composed of sequence of one or more characters. A legal character is an uppercase letter or a lowercase letter or a digit or the underscore characters. So whatever the user identifiers we use in VHDL, so we have to use only letters, numbers and underscore symbol only. And the rule is the first character is an identifier must be a letter. Okay, so A to Z letter, and the last character may not be underscore. So any user identifier starts with a character and cannot ends with a underscore. So here lowercase and uppercase letter are considered to be identical when we use in an identifier. If you use small a or capital A, both are considered as A, right? So next topic is data objects. So a data object holds a value of a specified type, means a data object holds a value. So it is created by means of an object declaration. An example is, this is an example how we can define a data object. So variable, count, variable type. So we have three types of data objects: constant, variable and signal. So how we can define constant, variable and signal we will discuss now. So first one is constant. So constant is a object class which can hold a single value of a given type. So it will hold the values which are constant. So this value is assigned to the object before the simulation starts, and the value cannot be changed during the course of a simulation. So we will assign a value to the constant, and this constant value cannot change during the simulation. Okay, so any constant can be defined, can be given by the syntax of a constant is like this. So any constant starts with the keyword constant followed by constant name. It is an user identifier. So we have to follow those rules. Means, so user identifier starts with a letter and cannot be end with a underscore, right? So then type of a name, we have to write different types, signal types we have discussed earlier, and the value. So whatever the value we have given here, that value cannot be changed during the course of the simulation. So example of a constants are constant. So this is constant name, and the type of rise time is time type, and the value is 10 nanoseconds. So here rise time is nothing but 10 nanoseconds. So next constant is constant bus width. It is type integer, and the value of bus width is nothing but the 8. So this is the constant. This is about constant. So second object is variable. So an object of variable class can hold a single value of a given type. So however, in this case, different values can be assigned to the object at different times using a signal assignment statement. Okay, so how we declare a variable is, so the variable declaration has the following form. So variable, variable name, variable type. So one more important topic in variable is, variables are only visible in behavioral style. Means in process statement only we can use variables. Okay, so this is an example. Variable D is variable name, and this type is signal type is bit type. So D is only either 0 or 1. So and the variable can be defined as variable. So this is variable assignment statement. So colon equal to is known as variable signal variable assignment statement, and this is expression. So this is an example, D colon equal to variable assignment statement equal to 0. So here the variable D value is 0. Okay. So and variables are only visible in process statement. Okay. So process, then declaration part, there we have to define the variable, and these variables are local to that process statement. So next data object is nothing but signal. So a signal can be defined in process statement or in architecture body also. So architecture declaration parts, there we can declare a signals, or process sensitivity list and declaration part, there also we can define the signals. If we define a signal in process statement, then that signal is local to that process. So we have to use that signal before end process statement. Okay. So whereas variables are visible only in process, but signals can be defined in architecture, either it may be a data flow or structural style or behavioral style. We can define these signals in process statement or in architecture declaration part. So an object belonging to signal class has a past history of values or current values or a set of future values. So future values can be assigned to a signal objects using a signal assignment statement. Signal objects can be regarding as a weights. So mostly weights are signal circuits. So the variables declaration has the following form, means the signal declaration has the following form. So any signal starts with the keyword signal followed by signal name colon signal type. So here we have to write the type of the signal. So example, signal X bit. So here signal is a keyword, X is a user identifier, and signal type is bit type. So if we have more than one bit, we have to use bit vector. So these are the some of the example how we can declare a signal. And a signal can be defined by signal name gets expression. This is signal assignment. So signal name gets expression or value. So these are the example. X gets expression, not A, or Y gets the value of Y is 10101. So mainly we have three types of data objects: constants, variable, signals. Constants are if we give any values constant, so during that simulation that value is constants. Variables are visible only in process statement, whereas signals can be defined in variables or architecture. So thank you so much.